Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about one more topic on Turing machine, that is Universal Turing Machine. But before we start, a small information I like to share. In this channel, we produce every video in 2 different languages. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. Before going to learn about Universal Turing Machine, let us see what is a universal language. A universal language is a set of binary string which can be modeled by a Turing machine. Basically, we represent it in the form of a pair, that is M and W, where M is the Turing machine and W is the binary string. Basically, we represent this in the form of A with M and W, where M is the Turing machine that accepts the language W. And the language A is called Turing recognizable. Why we are saying it is Turing recognizable? Because the Turing machine either will accept the string and halt, or reject the string and halt, or go in a infinite loop. That's why we'll say recognizable. In order to understand Universal Turing Machine, there is an important question. If the description of a Turing machine and the input is given, can we determine whether the Turing machine accepts it? This leads to the thinking of a universal Turing machine. Basically, we have a machine that accepts the string W. When we pass the machine and the string W to a universal Turing machine, the universal Turing machine may accept and halt, reject and halt, and it may go into a loop. Basically, we are passing the Turing machine into a universal Turing machine, and the universal Turing machine will behave the machine M behaves. So, universal Turing machine works in the same way as any other Turing machine. So, if M accepts the string W and then the algorithm accepts and halts, if M rejects W, then algorithm reject and halt, and if M loops on W, then the algorithm goes in a loop. It will not halt at any point of time. So basically, for a universal Turing machine, we give the description of a Turing machine and an input string. And the action that we perform is to simulate the Turing machine, and the universal Turing machine will behave like a Turing machine. We can think universal Turing machine as a computer and Turing machine as a program. Why? Because any program we write, it doesn't run by itself. The program is simulated by the computer and we get the result in the computer. But the program actually gives us the output and we try to perform it in the computer. So can we think that the Turing machine is a computer? No, Turing machine is not a computer, because Turing machine has an infinite tape and we don't have a concept of infinite tape in a computer. And apart from that, we say in a Turing machine, it is an infinite memory. And for any computer, we cannot say the memory is infinite. So that's why we cannot say the Turing machine as same as a computer. So basically, a Turing machine is a recognizer but not a decider. The universal Turing machine takes the encoding of the Turing machine and input as its input in that state and behaves as a Turing machine on the input data. Let us take the specification of a Turing machine. We represent a Turing machine by this 7 tuple, and in this case we are having Q as A, B, C, D as state, Q0 as the starting state, that is A, and the tape symbol and the input symbol are 0 and 1, and the final symbols are B and D, and the transition is given in this way. And if you want to write this specification, then we can write A, B, C, D, then $01, then $01. Dollar is used as a delimiter or a separator here. So this specification along with the actual input data would be the input for the universal Turing machine. And this can be encoded in binary by assigning number to each of the characters appearing in the Turing machine specification. Now, Let us give some kind of encoding to it. Let us say dollar becomes 4 zeros. A is 001, B is 0010, C 0011, D is 0100. Then the input symbol 0, I am writing 0101. 1 is 0110. Moving left is 0111 and moving right is 1000. So this is the encoding for the specification that we have given earlier. So the sequence of actions that we perform in a universal Turing machine is, when we take Q0 as the starting state, we will be loading the input in the Turing machine specification. Then we'll go back and find which transition to apply. Then we'll make changes where it is necessary, and then we'll store the changes and repeat the steps with the next input symbols. So it can be understood by this figure. We'll be loading, then decoding, executing, storing. Again we'll come and take the next instruction. I hope you understood what is a universal Turing machine and how it works. If you understood, give me a like and share among your friends. In our next video, we are coming with one more topic in Turing machine. See you then. Take care. Bye.